Hello, today I'm just going to showcase my most recent application here that I've managed to pull off. It's pretty interesting, so I'm going to want to share with you. So basically, I'm going to explain what it does, I'll showcase it, and I will explain a little bit how it works under the hood. So basically, I have an SQL file with some insertion into this specific table. It could be other tables. I would just have to adjust the script a little bit, but this is from old versions of DD Tank, versions 4.1, 4.2. They usually use this table for some storing items and stuff. And it has a bunch of columns here, and it has the values I want to insert into each column. But as they come from different sources, they essentially are in many different languages. They are in Turkish, Thai, Mandarin, and as you can see here, many different languages, and I want to translate it into Portuguese because I want to use it into Portuguese. But the idea is I'm going to parse this file. I'm going to fetch all the information that I want. I'm going to translate via the Bing API. I'm going to do it via a data frame, and I'm going to apply the function that will translate into the data frame. But before that, I will vectorize everything into NumPy. I will divide the data frame into multiple data frames and pass it into a multi-threading function that will concurrently connect to the API and will make it way faster. Essentially, I've tested it with and without the concurrency and multi-threading. So with the concurrency, without the concurrency, it was taking around 18 minutes and 40 seconds to do the whole file, and with the concurrency is going around 40 to 45 seconds, so it's a lot faster. The file essentially has 500 lines, but as every other line I'm jumping, it's an empty line. It has 250 lines of data, and the main goal here is to only translate what has to be translated. So the name column and the description column here, okay? And I'll showcase the application first, just to make it a little bit easier. And at the end, I will just spit out another SQL file with everything translated to Portuguese, and without these spaces here, they're useless. And I will also speed everything into an Excel file so I can read more easily and check if any translations were wrong. So first thing I want to do is, let me just activate my VM here real quick. Where am I? So VM scripts and activate, and then run the script here, translate.py. So as you can see, everything that shows up here, these are the columns that are getting currently translated, the elements that are getting currently translated. As you can see, it's pretty quick. We have 250 lines for the we have 250 lines for the name and 250 lines for the description. We're basically done with the names, and now we're gonna start. Okay, we're getting 503 error. So on top of that, I have some exception handling. So if it fails to translate something, I'll try to retranslate that line at least 5 times. So that's why I retry it, so I don't lose any data. And we're basically done with the names, and now we're gonna do with the descriptions. The descriptions are a bit larger, so there are bigger chunks of text. And once we're done, we're gonna get the files right here, so just make it a little bit easier to see. So here it is. So let's check if we have any failed translations. So no, the retries were successful. So we didn't have anything that failed. So every single line got translated. It took 1 minute and 22 seconds. When it doesn't fail anything, it usually takes around 40 to 45 seconds. So it's a lot faster. And in here we have the translated columns in the Excel format. So in Portuguese here and here. And the translation is kind of rough, but it works good enough. So we can just infer some things. If the translation doesn't look that good, we can rearrange things manually here. And we also have it in SQL, so the translated SQL. So every single line here, as we stated, we had 250 lines of data. So we have here 250 lines translated. And if we take a look here and we compare it, these are the translated versions for the names, and these are the translated versions for the descriptions, and it's pretty good. It works pretty well. If you wanted to change something because it doesn't look too natural, we can manually change a few things. That's why I've also set out in Excel, so it's easier to spot anything that is odd. It's easier to read compared to reading here on the SQL format. So we just find the column we want to change, and we search the ID here, and we change it manually, and that's it. So it's pretty cool, but that's the whole application. That's what it does. It can handle way more than this. It's just this is only like 250 lines, but the idea is to use it in a very big data set. It has more than 72,000 lines, so it's not viable doing it by hand. So that's why I created the script. And the parsing was a little bit odd to do because a lot of things were not returning the correct way I was expecting. But let's get into the details a little bit. Basically, what it does is I read the original file, and I basically remove every single break line because the break lines are only in between the lines, so nothing inside the lines. And I basically fetch the column names. So as you can see here, there are column names, and I want to fetch everything here. So the way I do it is pretty simple. I get the first row from the database from the I get the first row from the file. So this one, because every single one is equal. So I get the same. They're the same. I get the first row, and I parse it. So I find the first and the last. I find the text between the first and the last parenthesis, and it will give me all these text here within these square brackets, the separated by comma space. So I basically remove every parenthesis and square brackets and spaces, and I will split it into a list via the comma here. So I'll get every single column name inside the list. So that's what I'm doing here. This was pretty easy to parse because it's pretty standardized, so nothing too crazy here. The second thing is I wanted to fetch the schema and table name, so I can save it. I want to save the schema and table name because I don't need to put it into a separate column in my data frame. I just save it in two variables and reuse it later to reconstruct this file in this format. So basically, let me close this right now. I'm not going to use that right now. So to fetch it, I get the first row. I find the first parenthesis, and I'll go up to that first parenthesis. So I get from this first character up to here, and then I will split into this dot. So you can see I split into the dot. The first element is this one, and the second element is this one. And I get the text in between each square brackets for both elements, and I'll get the schema and I'll get the table name. Okay, that's pretty easy as well. Second thing I'm doing here is let me say I permeate the values on the data frame. So as you can see, I also have to fetch the values and put it into a data frame that has these columns. So that's why I fetch the columns. So I can create a data frame with all these columns and put each single value inside its respective column. So inside this function here, as you can see here, where is it? So I create a data frame with all the columns we have. I create a data frame with raw data because I'm basically storing every single line as a string. So this raw data is basically a data frame with every single line as a string, and I apply this function called fetch values, so I can parse everything that is in between that is after the values keyword, and that is in between these separated by commas, and I simply ignore every comma that is within this single quotes. So this regex here is essentially ignoring. I'm separating everything by comma space, but as you can see, we have some comma spaces in between the single quotes here, and I don't want to split here. I want to split only after the whole single quote has been done. So that this regex basically says that we're going to ignore every single comma space within quotes, and I split it into the values into a list, and I put it back. And I return this value here, and I'll split into these columns. And this data frame has the columns we've extracted before, all these columns. So we're basically permeating all the values we get from each line within this new data frame in each respective column. And if we find something if we insert a row that is essentially empty, we just drop it. So this is to avoid any empty rows that are not useful for us, and we return the data frame with every single value permeated. That's basically what it's doing. And with this data frame, we can now translate it, and this is where it gets a little bit more interesting. So what I did is I get the columns that I want to translate. So these are only the name and description, and for every column within this column to translate here, I'm going to apply this function in parallel. So I'm using triple execution, so I can run things concurrently and run them way faster. So I've created this function here called parallel apply. It receives the data frame with its respective column I wanted to apply the function to, and the function I want to apply concurrently. So this translate text with delay is the function that will actually translate, but I'll explain how I'm actually doing the parallelization here, the concurrency. So when I call this function, I split my whole data my whole data frame with with that respective column. So for example, I'm first going to translate all the names. So I get my whole data frame with only the names here. I split it into partitions, into a number of partitions that I've defined here. So I split this data frame into 20 equal pieces. And this is a NumPy array, so it's vectorized. And this data split is basically my data frame name column split into 20 pieces, so within a NumPy array. So this is a NumPy array with each element in the array being a data frame, being a piece of my data frame with the column name that has the total number of columns I have divided by 20. And I'll call this process pool executor that will run things concurrently, running this apply func here in my list of data frames. And I also have to pass the function I want to apply, and I have to do it with a list. So a list the same size of the partitions here, because this has 20 elements, and this also need to have 20 elements. That's why we're passing this argument of func within the list 20 times, so number of partitions times 20. We're multiplying the func in here so we can spread it around within this list 20 times. That's basically it. And this apply func will run concurrently 20 different times, and we're basically getting each single piece of our data frame that has 1/20 of the total data frame size, and we're going to apply this function here. And this function is the translate text with delay. And what we're essentially doing is, in this function that we're actually translating the text, we're finding the everything in the text that it's not outside of the single quotes, because if you look here, I have an n in the text is after this n in single quotes. So I'm just removing this n in single quotes just to get the raw text here. So that's essentially what I'm doing here. And I'm passing this text to my translate function. And this is just so I can retry if anything fails. But if regex fails, meaning that it was a null element or anything like that, I'm just going to ignore this element, meaning that it was a null value that doesn't have to be parsed. I have a number of max attempts here. It is 5, and I don't know why I haven't switched that. We can do it right now. Let's set it here. Max attempts. Let's just real quick set it here. Max attempts equals 5. So I have 5 max attempts for each single line, and we start trying to translate the sentence, and I print which sentence is being translated at that time, just to give it the user the impression that something's actually happened instead of just a blank CMD blinking. We have a sense of progress, and then we're going to try to translate this sentence, and this is using the Bing API. So I'm using this library here, this library called translators. So I'm essentially getting this. I'm creating a translator, instantiating a translator object from the translator class, and it has some pretty interesting properties, and it's pretty easy to use. So the translate function, what it essentially does is I get the text I want to translate. I'm not even using this standard delay anymore. I can remove it. I was just messing with delay, but it takes quite some requests until you actually need to add some delay between the calls. So I'm not even going to use it. I'm just straight up blasting the server with API requests. So basically, I get the text I want to translate. I set a variable called translated text to empty string. If anything goes wrong here, I at least just give it back a parse string, empty parse string, so I have a value to return. But if I have something that I want to translate, meaning that the string is not null, I will first translate the text using that library. The text I want to translate, I pass in here. I'm going to translate. I'm using the translator, the Bing API, the Microsoft API, and it's free and it's pretty good. And I want to translate initially from auto recognition, because I don't know which language I'm translating from first, because there are many different languages here, as I've shown you. There is Vietnamese, Thai, there is Mandarin, there is Turkish. So I wanted to auto recognize it and translate it to English. After that, I have a translated text into English. So I want to translate from English to Portuguese, and I translate it again from this is supposed to be Portuguese, but I've set it to auto and Portuguese because sometimes some terms within the English sentence don't get fully translated into Portuguese. So translating it twice makes it that a few of the sentences that didn't get translated very well, they get translated a little better. It's not 100%, but you know, I find it nice to have twice. 2 lines translated back to Portuguese. So this is essentially what I'm doing. Translating from some language that I don't know to English, and then from English to Portuguese, and then I try to retranslate what I've just translated to Portuguese again. So if any terms didn't get properly translated, they sometimes get properly translated to Portuguese. And then I remove anything that has single quotes or double quotes, because this would completely fuck up my SQL structure here. So if I have a single quote within here or a double quotes within here, that wouldn't be very nice. That would just completely destroy my SQL file. And then I just return this translated text in the format, in the original format, with n double single quotes, the text, and closing single quotes here. So this is the translate function. Everything is going to get translated that way. Once I translate the text, I will have everything translated and returned into a list. So this executor map will return everything from here. So we return this apply function, and each apply function will return a data frame. Okay, so this will return a data frame, and we're getting a list of data frames. And after that, I just concat all the list of data frames within a single data frame again, and that's how we get our original data frame translated. So from here, after this parallel apply, after this translate columns to df, we get a data frame that is completely translated, but it's not in the SQL format. So I have to I first export this translated data frame to Excel. That's the same Excel I've shown you here. So this is the structure of the translated data frame. This is the name column translated and description column translated. And from this data frame, I'm just going to basically create a different data frame with a single column called translated SQL. And I'll reparse everything into a single string. So every single line of this data frame will become a single string that I will convert back into string format via this function. So I'm applying to each and every row this convert to string format, and I'm passing here the schema name and table name so I can reconstruct it back to this format that I'm showing you here. So this insert, the schema, and the table name. And this function is right here. So it's pretty simple. I just get the whole row, transform it into a list. I join it using the same pattern we were using before. So the data is inside these square brackets and separated by column space. So we'll get this result here. These are the columns. So we're reconstructing the columns. And the values are basically the values separated by comma. So this is CSV, comma separated values, like this. So we just join the list of values back in here. And then we recreate the string from insert, the schema name, table name, the columns, and then the values here. So this will give us back the original SQL string format here. And from here, after I have a data frame that has basically every single row back into an SQL string format, I just simply export it to a translated SQL. So this is the SQL, the translated SQL. So this is the final result. It works. No syntax error in the SQL file, and no missing values here. Everything is fine. So after all that parsing, everything is working fine. And last but not least, I have this global manually translate list. Basically, if anything fails 5 times in a row, I insert it into this list. So if it fails 5 times to translate the sentence, I append this text into this manually translate, so I can put into this failed translated or failed translations txt file, so the person can actually know what actually failed the translation and go to the file and translate it manually. And that's it. After that, I just output the manually translate anything that went wrong into this failed translations txt. If nothing went wrong, I just print it here, no failed translations. Translations failed in 0, so nothing went wrong. And I basically show here the time that the script took to execute every single step to the end. And that's it. I just wanted to showcase a little bit how the script works, what it does. So it's pretty interesting, right? It's pretty okay project to test Python skills and dealing with different file types, dealing with parsing strings, and getting everything into data frames, using some vectorized functions and parallelism to make things a lot faster. Because if you don't use concurrency here, multi-threading here, you will basically get this code to run like in 20 minutes. So it's pretty shit. So from 20 minutes to like a minute, it's 20 times faster just because I'm using this. I'm literally using multi-threading. So it's pretty important to understand a little bit how to use this concept, and avoid as much as you can iter rows. Just use apply, and that's why I'm using apply. I'm using apply even within the multi-threading, and everywhere I want to apply something to all the columns of the data frame. Don't use iter rows, just use apply, and try to, if it doesn't fit right away the syntax you're expecting, just try to make a workaround that uses apply or vectorized functions, because it's going to make your code way faster, right? And that's basically it. Thanks for watching. And if I do create a different project that I find interesting to share with you, I will be sharing with you guys very soon. So see ya.